Hello class, how are you? I am your teacher in Journal Physics 1. I am Hanisa and Francisco Baraguer, and for our first lesson, we will be discussing about measurement. Learning measurement is very important when we study physics because the ability to identify the correct measurements in experiments and other related activities is very important. When you say measurement, it is composed of number and a unit. So to have the correct measurement, you should have both number and unit. For example, in length, the correct measurement will be 1 meter. If you will only write 1, so 1 is not a correct measurement for length. Later on, measurement have evolved in two systems. We have the metric system and the English-British system. When you say metric system, this actually constitutes units based on powers of 10. And this is the preferred system to be used in science. For example, 1 kilometer is equal to 10 to the third meters. On the other hand, when you say British or English system, this comprises units such as pound for force, yard for length, and ounce for volume. So, in France, an international conference had happened and they have evolved into the 7 base units, which are mass, length, time, amount of substance, temperature, electric current, and luminous intensity. And these 7 base units have the international system of units. For example, in mass, the SI unit for mass is in kilogram. For length, we have meters. For time, we have second. For amount of substance, we have mole. For the temperature, we have Kelvin. And the electric current is ampere. And the luminous intensity is candela. In addition to the 7 base units are the other SI units that can be made from combinations of 2 or more base units, which is what we call derived unit. So derived units are usually used when 2 or more base units are combined. Common derived unit example is when we identify the unit for volume. Remember that in getting the volume of a regular solid, you have considered its length, its width, and its height. So in getting the volume of a solid, you'll have volume is equal to length times width times height of the regular solid. Therefore, the unit of volume is in cubic meters. On the other hand, there is also a letter or a group of letters that can be added at the beginning of the base word to change its meaning. And that is what we call unit prefixes. These unit prefixes are used to make a new unit that is larger or smaller than the base unit. For example, prefix centi is equal to 10 times the negative 2. The milli is equal to 10 to the negative 3. Micro is 10 to the negative 6. And the prefix nano is 10 to the negative 9. For example, the wavelength of the green emission line in the spectrum of hydrogen is about approximately 486 nanometers. So you have to express this length in meters. How are you going to do that? You have to recall that n is the abbreviation of nano, which is equal to 10 to the negative 9. So therefore, 486 nanometers is equal to 486 times 10 to the negative 9 meters. So in scientific notation, that is 4.86 times 10 to the negative 7 meters. In scientific notation, is to be discussed later on. Many problems in physics require the conversion of unit measurement to one another. And this technique is what we call dimensional analysis. And the starting point for dimensional analysis is unit equity or conversion factor. So this is usually an equation that shows the equivalent amounts of different units. You have to recall, for example, that the unit 1 inch is equivalent to 2.5 centimeters. 1 gallon is also equal to 3.758 liters. 1 calorie is equal to 4.184 joules. 1 atmosphere is equal to 1,325 pascals. 1 foot is equal to 12 inches. And 1 mile is equal to 5,280 feet. For example, how many inches are there in 12 meters? What you have to do is you have to recall what is the equivalence of inches into meter. You have to recall that 1 inches is equal to 2.54 centimeters and 100 centimeter is also equal to 1 meter. So to get the value of 12 meters into inches, you use this. You convert meters into centimeter first, and you know that 1 meter is equal to 100 centimeter. So meter divide meter is equal to 1. We only have centimeter here. Therefore, you just put times 1 inches over divided by 2.54 centimeters. And centimeter here divided by the centimeter is also equal to 1. So we can cancel that out. Therefore, we are left with inches. So basically, what you do is just you multiply 12 times 100 divide 1 times 1 divided by 2.54 is equal to 472.44. And what unit we have left is inches. So we have inches. Therefore, there are 472.44 inches for every 12 meters. Another example, the speed of a car as measured by a speedometer is 85 kilometers per hour. How fast is the car moving in centimeter per second? So what we have is 85 kilometers per hour. We are asked to convert the unit into centimeter per second. So you have to recall that 1 kilometer is equal to 1,000 meters and 1 meter is equal to 100 centimeter. 1 hour is equal to 3,600 seconds. So what we have, the velocity of the car is equal to 85 kilometers per hour. That is given. We will convert kilometers into meters first. So you'll have, you multiply that into 1. 1 kilometer times 1,000 meters. So kilometer over kilometer is equal to 1. We can cancel this out. So we'll have meters per hour left. So we will convert meter into centimeter. And we know that 1 meter is equal to 100 centimeters. So the unit left is centimeter per hour. So we are asked with centimeter per second. Therefore, we will now convert hour into seconds. And we know that 1 hour is equal to 3,600 seconds. So we will just simply multiply this all. That is 85 times 1,000 divided by 1 times 100 divide 1 times 1 divide 3,600 seconds rather. So we'll have the velocity of the car is 2,361.11 centimeters per second, and that is also equal to 85 kilometers per hour. Okay, so if we have measured data which are very large or very small, we can write that into scientific notation. So a scientific notation is used in writing numbers which are very large or very small, and it has two parts. We have the numbers from 1 to 10 and of course a power of 10 in exponential form. Let's have an example. If this number 199,000,000, this zeros, kilogram, if we want to convert that into scientific notation, let's move the decimal point to the left. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So our decimal point is moved from the last of the zero between 1 and 9. We'll have the scientific notation of 1.99 times 10 to the 30 because we have moved the decimal point 30 times. However, if the decimal point is moved to the right, the exponent of the scientific notation is in negative. However, if the decimal point of the number or the measurement is moved from right to left, our exponent of our measurement in scientific notation is in positive sign. In writing measurements, you have to write both the certain and the uncertain digits of measured data. When you say certain or exact digits, these are the measured or the one that is given by the measuring instrument, and the smallest marked division in the measuring instrument is called the least count. On the other hand, uncertain digits are the ones that you just estimate based on your activity. In doing an experiment or getting the measurement, it is very important that you always have to make sure that you have reliable measurements. One way to do that is to repeat the measurements several times. This is where precision and accuracy comes in. When you say precision, this is the closeness of the value to one another, and to identify, you can actually describe the consistency of the measurements numerically using variance. And variance can be calculated by the summation of x minus the x bar squared over n, where x is actually the actual measurement and the x bar means mean or average of the measurements, and n is the number of measurements that is done. Okay, for example, 5 of your classmates measured the diagonal length of the board. Classmates A measured it as 2.54 meters, classmate B as 2.46 meters, classmate C as 2.65 meters, classmate D as 2.55 meters, and classmate E as 2.39 meters. Find the variance in the standard deviation of the measurements made. Express the average measurement in a form that includes uncertainty. How are we going to do that? So you just identify what are the measurements. We have this. These are the 5 measurements made by your classmate. First step is to compute the mean or the average of the measurements. To get the mean of measurements, you just add all the measured data divided by the number of measurements. In this case, we have 1, 2, 3, 4, and 5. Therefore, we will divide it into 5. So our mean is equal to 2.54 meters plus 2.46 meters plus 2.65 meters plus 2.55 meters plus 2.39 meters. All of that is divided into 5, and that would equal to 2.518 meters. You have to recall that the mean is 2.518 meters because you will use that in our next step. So our next step is we have to make a table for the calculation of deviations, which is the standard data or standard measurement minus the mean, and square of deviations, the value of x minus the mean. You square that for each measurement, and you have to take note of the consistency of units. Note again that your mean is 2.518 meters, and for example, your measurement A is 2.54 meters. To get x minus x bar, or our measurement minus our mean, you can use for measurement A, you have 2.54 meters minus our mean, which is 2.518 meters, and you will get 0.022 meters, and we will put that on the table. And the process goes along with the measurement P, measurement C, measurement D, and measurement E. How are we going to get x minus the mean squared? So you just have to get the value of this. You square that. For example, 0.022 meters, you square this and you will get 0.000484 meters squared. Or you can just directly multiply this number into itself. For example, 0.022 meters, multiply that into 0.022 meters, you will also get 0.000484 meters squared. And you do that process until you can get that value. Next, you have to solve for the variance. In getting the variance, it is very important that you get first the mean of our measurement minus our mean squared. So you just substitute that into our variance formula. We have variance is equal to the summation of x minus our mean quantity squared over n, which is our population. So you just get the value of this is from here. You just copy that and you substitute that into here, and you get all of those values. You divide it into 5 and your variance will equal to 0.007736 meters squared. And this value is used to get our standard deviation. How are we going to get our standard deviation? You just simply square the value of your variance. Remember that the value of our variance from our previous calculation is equal to 0.00773 meters squared. To just get the square root of that, using your calculator, you will get approximately 0.088 meters. Okay, you can also estimate the standard error of the mean by dividing the standard deviation with the square root of the number of measurements done. For example, we have the value of our standard deviation that is equal to 0.088 meters. You divide that into the number of population, which is equal to 5. Therefore, we have 0.039 meters. Therefore, our average measurement is equal to our mean plus or minus our standard error mean. Therefore, we have 2.518. This is our mean plus or minus our SEM, which is equal to 0.039 meters. Okay, on the other hand, precision is the measurements of how close the measured value is to the true or accepted value. For example, in this figure that is shown in figure 1.4, for figure 1.4a, it shows a very high precision, but it has a very low accuracy. Why? Because the target is at the center. Therefore, your dart is very far from the center. Therefore, it is very low, or it is not accurate. However, the value are very close to one another. Therefore, it has high precision. For figure 1.4b, your data or the dart are almost close to the center. Therefore, higher accuracy than figure 1.4a. However, the values here are a little bit far from one another. Therefore, they have lower precision. Figure 1.4c, and all the darts are actually close to one another and they are close to the target point. Therefore, it has high precision and it has high accuracy. because they are very close to one another and it has a very close position to the target. Well, I hope you have understood our discussion on measurements because measurements is our key to understanding physics. I hope you will enjoy physics from today up to the end of our discussion.